Okay, number 4 is 0 because we come up with two different equations. 5x plus 5 equals 10x plus 5. So our solution is going to be 0. And number 5, Stephen?
I got 52.
52.
Just keep it on the day.
Wait. I get 2 plus 3.
Wow.
Not Thursday.
Oh, wait.
All right. Hush. Okay, we took that pretest yesterday, and a lot of you didn't understand it. So I'm going to show you some things that will make it a whole lot easier.
Can we see what we got on the test?
It's posted.
Not that great
Try
at
to look
that.
them up.
Because they still show even though they're not for grade, right?
Yeah, they just have a little asterisk mark saying not
Yeah.
not putting the final.
Okay,
grade.
so we're going to talk about how to graph a solution to inequalities in standard form. Okay, what does the word intercept mean? Jacob,
Where the lines cross.
the lines cross or where they cross. Intercept is actually where they cross the axis. The intercept is where they cross either the y-axis or the x-axis. Okay, so that's the
Put some respect. on that.
x-intercept and y-intercept. Because the point of intersection may not be anywhere near the axis. Okay, the point of intersection might be way out here and nowhere near. But the intercept is where it crosses the axis. Okay, so earlier we learned how to take an equation like this and graph it. It was very easy to do. We turned it into y equals mx plus b form. We knew that the b is the y-intercept. We could put a point there. The m is the slope. We could measure from the y-intercept by the slope till it crosses the x-axis, and we had the x-intercept, right? That was all really easy. Well, in math, there's always more than one way to do something. So I'm going to show you a harder way today because you need to know more than one way. Okay. So, if we take this equation and we want to find the, let's start out with finding the x-intercept. I'm going to say 2x plus 3 times 0 equals 12. And I'm going to solve this for x, so I have 2x equals 12. Divide by 2, x equals 6. My x-intercept is 6, 0. My y-intercept would be, I do the same thing, I say 2 times 0 plus 3y equals 12. That goes away, I have 3y equals 12, divide by 3, y equals 4. My y-intercept is 0, 4. So if I want to graph this equation on a line, all I have to do is plot 6, 0, which means go over 6 spaces, go over 6 on the x-axis, and stay right on the axis because it's 0. Put a point, then go stay at the midpoint and go up 4 and put a point, draw a line between those, and I've graphed my equation. So, see what I meant? This is a lot harder than doing it the other way.
No, it's not.
Thank you. Get somebody to comment on that. Okay, so to find the x and y intercept, all you have to do is replace the other one with 0. So I could do the same thing with this. This is a different equation, even though it looks the same. It is different because it's minus 3y instead of plus 3y. Okay. So what's the x-intercept when y is 0?
0.
What's the x when y, if y is 0, what's x?
6.
6.
Why is it 6?
Because if
We
y
Oh
is,
my God.
What we just did.
if y is 0, I'm going to then have, if this is 0, I've got 2x equals 12, x equals 6. So what's my y-intercept?
4.
Look at it again. -4. Thank you, Carson. Because it's a minus 3y. The other, first time we did it was a plus 3y. Okay, so this shows you exactly what I just had shown you. Shows you the steps. And you would graph them then as 6, 0, and 0, -4, and connect those two to make a line. Okay, and remember when you're graphing on a, when you're graphing a line, you don't just go point to point. You want to go beyond, so that you can get find your point of intersection.
I cannot do that.
It's the same.
So these are inequalities now. They're not equals. They're both greater than or equal to. So if I take the first one, I've got 2x minus 3 times 0 is greater than or equal to 6. 2x greater than or equal to 6. X greater than or equal to 3.
That sign is very confusing.
Do my y, and they have 2 times 0 minus 3y greater than or equal to 6, or minus 3y greater than or equal to 6, or y less than or equal to 2. Okay? And remember when I got to this one, it was a minus 3y, so I was dividing by a negative. I had to flip my sign.
Yeah,
Flip my sign. To graph this now, I would show it, I would do the same thing. I would plot x at 3, 0, and y at 0, oh, that's a negative, 0, -2. Y at 0, -2. X is 3, y is -2. And then the second equation would be x is 3, y is 2. Where's my point of intersection going to be? It'll be 3, 0, right? Because they both have, x is a positive 3, but the y's are different.
Oh,
The x is a positive 3, but the y's are different. So when I graph that, 3, 0, and 0, -2, it's going to look like that. Now remember the shading that was on that pretest yesterday?
Yeah, the greater than.
Oh,
And you knew which way the shading went, right?
Mhm.
You know, you kind of, some of you were just, I think, kind of guessing at it, but you guys, a lot of you are pretty good guessers.
Yeah.
To find out which way I'm going to shade, I want to look, I'm concerned with this right here. The point of origin. Okay, when I talk about point of origin, I'm talking about 0, 0. If I take my point of origin and I go back to my equation and plug it in for x and y, do I have a true statement or a false statement?
False.
Because 0 is not greater than or equal to 6. I have a false statement, which means I'm going to shade away from my point of origin. I'm going to shade away from it. If I had a true statement, I would shade over it.
what?
Okay.
Okay?
What's a true statement?
See, when I put in 0, 0 and test it, I have a false statement, so I shade away. I graph my second equation, and it looks like so. Where am I going to shade this? Am I going to shade it to the north or to the south?
North. Yeah.
Okay. North is above it, south is below it.
North. No.
West.
Southeast.
When I put in 0, 0 for my test, I come up with a false statement.
Is it all
I don't know what the test is.
The test is you take 0, 0 and put it in the equation for x and
You're
y.
never gonna get true then.
What?
Then you'll always get
Like
false.
No, you won't.
Absolutely.
How do you-
0 though.
Okay? So to test it for true or false, you take your point of origin, which is 0, 0, and plug it into the original equation. X is 0, y is 0. If x is 0 and y is 0, does that make that a true statement?
No.
No, so it's false. So I shade away from, or away from.
Oh, so no matter what, it's always if the equal sign. So if that was like -4, if it equal or less or 2, whatever, 0 would be more than -4, so it'd be true.
North can be down, down.
So then, if it's true, you go away from it. I mean, if it's true, you go
Over it.
over it, and you also go away from it. Okay. Why is that one green?
So, when I shade these, now I have an area that both equations shaded. Okay, they overlap each other and shade that green or yellow area. Okay, because I shaded away from the origin. The green section is double shaded. So the graphing solution is just that area that meets both equations.
Oh.
So my system of equations solution is that area there on the graph.
What's the usefulness of this? What do you use this for?
Everything,
Yeah, but like, when will you ever draw a graph?
all the time. If you'd have been here the other day, you'd understand, but you missed class too much.
I was sick.
That's
Yeah,
your,
no
excuse, what's
It's your
the
fault.
The videos were uploaded? What?
Okay, so I'm going to stop there. Do you see how much now that makes it so that that test yesterday made sense?
Yeah, North is always
North is always above. When I talk about north and south, north is up, south is down, east is right.
I'm talking about like the real like, south is not really, it's not really.
Oh, okay. I know how to figure it.
That's
I
like
already.
saying I
Come on, you're on the searcher.
Oh,
No,
that's good.
but you don't know what that's the same way now.
No, yeah.
Two
No, you're right.
North.
Yeah, see.
No,
It's
south.
North can be. No. I was, there's like a couple lines like, right there.
You've never said it.